today we're going to talk about calculations with sample means. Let's say I am given a situation where I know the length of human pregnancies from conception to birth, and it varies according to a distribution that is approximately normal. So I know that the distribution is approximately normal. I'm then told that there's a mean of 266 days. The population mean is 266 days. And the population standard deviation is 16 days. If I was to draw a picture of this for my population, my average falls at 266, and then one standard deviation over would be 266 plus 16, which is 282. I could calculate one standard deviation back and go back and forth so that I could perform normal calculations using the empirical rule, or this gives me a visualization so I can perform normal calculations. The first question is, I want to find the probability that a randomly chosen pregnant woman has a pregnancy that lasts for more than 270 days. So what is the probability that a randomly chosen woman has a pregnancy that lasts more than 270 days? This is the question that I'm being asked. The 270, as you can see from my picture, falls somewhere in between 266 and 282. But I'm asking for a greater than, so I'm talking about the probability to the right tail. So if I was to use a chart, I would need to find the complement. But in this case, I'm going to use my calculator, perform a quick calculation using a normal CDF rather than standardize, just for efficiency. So what I'm going to do in my calculator is I'm going to press second, and I'm going to access my distribution. I'm going to pull a normal CDF. My lower bound is going to be 270 because I'm dealing with a greater than problem. I'm going to pick a large bound. My mean for this problem is 266, and my standard deviation is 16. This gives me a probability of 40%. So roughly 40%. Now let's say I choose a sample. I choose an SRS of 6 pregnant women. So I have an SRS of 6. And X bar is going to be the mean pregnancy length from the sample. My next question that I'm going to ask is, what is the mean of the sampling distribution? So here I have a given population distribution. If I took a sample of 6, what would I expect my sample distribution to be? I know that the population distribution has an unbiased estimator in the mean. So the mean of the sampling distribution is equal to the mean of the population, which is equal to 266. Now I want to know the standard deviation. The standard deviation of the sampling distribution is not just a regular same as before. There's less variability than in the population distribution. So what I do is I take the population standard deviation and divide that by the square root of my sample size. This is equal to 16 divided by the square root of 6. Which gives me a standard deviation of 6.532. Or if let's say I go to 4 decimal places, 1 Nope, that'll be 2. There we go. Now I can perform a calculation based on the probability using my sample mean and sample standard deviation. So what is the probability that the mean pregnancy length for women in the sample exceeds 270 days? So what is the probability that X bar is greater than 270 days? So now I'm talking about the sample that I've taken and my mean pregnancy length. So this is going to be equal to a normal calculation still, but I'm talking about a different standard deviation. What I'm going to do is normal CDF, and I'm going to, let's say without writing it out, this is going to be the probability that Z is greater than 270 minus the mean over our standard deviation of 6.532. That's the calculation I'm going to calculate. I'm going to go second bars to get my normal CDF, starting at 270, going up to a really large number. My mean is still 266, but my standard deviation is now adjusted for the sample size. And I get 27%, which is roughly 27%. So when you're given a problem that talks about normal calculations, make sure you understand whether you're talking about the population or whether you're talking about some sort of sample that you're dealing with. That's all we have for today.